Download this code from codegive.com, link in the description below. Certainly. Let's dive into the concept of modularity in programming through games, using Python as our programming language. This tutorial will be inspired by concepts often found in educational platforms like Khan Academy. Introduction to Modularity. Modularity is a software design principle that emphasizes separating a program into distinct sections, or modules. Each module should encapsulate a specific piece of functionality. This makes your code more organized, easier to maintain, and reusable. In the context of game development, modularity allows you to break down different aspects of the game into manageable parts. For example, you might have separate modules for the game logic, user interface, and sound effects. Key benefits of modularity. Reusability. Modules can be reused in different parts of your game or even in other projects. Maintainability. It's easier to update or fix a single module than to sift through a large monolithic code base. Collaboration. Different team members can work on different modules simultaneously. Example, a simple game structure. Let's create a simple game structure in Python, where we'll define a game and its main components using modularity. We will create a game where a player can collect points by clicking a button. Step 1. Setting up the structure. We will create 3 modules. 1 game.py, this will contain the main game loop and logic. 2 player.py, this will handle player-related functionality. 3 UI.py, this will manage the user interface. Step 2. Creating the modules. 1. Player.py. Python. Class player. Def__init__self. Self.points equals 0. Def add_points, self, amount. Self.points plus equals amount. Def get_points, self. Return self.points. 2. UI.py. Python. Import tkinter_stk. Class game UI. Def__init__self, root, on_click. Self.root equals root. Self.root.title, point collector game. Self.score_label equals tk label, root, text equals points, 0. Self.score_label.pack. Self.collect_button equals tk button, root, text equals collect points, command equals on_click. Self.collect_button.pack. Def update_score, self, score. Self.score_label.config, text equals f points, score. 3. Game.py. Python. From player import player. From UI import game UI. Import tkinter_stk. Class game. Def__init__self. Self.player equals player. Self.root equals tk. Self.ui equals game UI, self.root, self.collect_points. Def collect_points, self. Self.player.add_points, 1, add 1 point for each click. Self.ui.update_score, self.player.get_points. Def start, self. Self.root.main loop. If ___name__ equals ___main__. Game equals game. Game.start. Explanation of the code. 1 player.py. A class player is defined with methods to add points and retrieve the current score. 2 UI.py. A class game UI is created using tkinter for the user interface. It includes a label to display points and a button that triggers the on_click function passed during initialization. 3. Game.py. The game class initializes the player and the UI. The collect_points method handles adding points and updating the score whenever the button is clicked. The start method runs the tkinter main loop, displaying the UI. Running the game. To run the game, ensure you have Python installed along with tkinter, which is included with standard Python installations. Save each part of the code in separate Python files named player.py, ui.py, and game.py. Then, execute game.py. Conclusion. This example illustrates the power of modularity in programming. Each module has a specific responsibility, making it easy to manage and modify. If you want to expand the game, you can add new features by creating additional modules without disrupting existing code. Feel free to experiment further by adding more functionality, such as levels, different buttons for collecting different amounts of points, or even sound effects. Happy coding!